Hello everyone and welcome to Robotics Robotics, and today I'm going to be doing stage 1B, exercise number 1, simple gearbox on frcdesign.org. So as you can see, this piece right here, it could take a while, but I found the most effective way by using the mirror and tangent commands to make this part not too difficult, and honestly you go pretty quick once you understand how to use like the really quick features. So let me just get right into it right here. So what you guys gonna want to do is you guys want to start a sketch on the front plane. Let's go over here, click the front plane, and we're gonna be using gears right here. So for gears to actually like mesh well, you guys have to calculate like the distance apart from them. And you're thinking, oh, like how do you calculate it? That might be a little bit difficult, but since we're using CAD, right, you could just have them touch at the tangent, and the tangents when they force intersect. So once they intersect force, that's where they're gonna start meshing. So how you actually use that, right? Like the formula, you're gonna want to pick show expression, and then now get yourself a center point circle. Make sure you have construction on because it's just a reference for us, and we're just gonna pop it right here. So the formula for this to actually get the gear in is you want to do the number of teeth it has. So we're going to be using a 60 tooth gear. And you always want to divide it by 20. No matter what gear it is, you will always divide it by 20. And as you can see here, we have a diameter of 3. And even though we could have run a diameter of 3, this is just makes it more streamlined so you understand, hey, that's a gear right there. So next thing you're going to want to do is you want to make the little gear right up here. Make sure we have a vertical constraint just by going up across the origin. And then this is going to be a 12 tooth, and you always divide it by 20. So that right there is now our 12 tooth gear. And as you can see, it's blue, and we don't like that. So we're going to have our tangent command right here. And we're going to select this and this. So now they intersect at one point, making them now mesh. So that is exactly what we want right over there. So next thing we want to do is get ourselves another center point circle. And we're going to make this construction as well. And right where we have the 12 tooth gear, we're going to extend this out and have this to be 2.5 diameter. And this right here is going to be for the motor, just a motor hole so that we could actually mount it, and just a reference for us. So once that's done, we're actually going to check mark this and create another sketch, this time on the front plane as well. We're going to be using the dimensions we just made as a reference for this sketch. So next thing we're going to want to do is want to go over to center point circle again. We're going to be using a lot of them in this exercise. So we're going to press it, and this diameter in the middle of the origin is going to be 1.125. That is going to be for the bearing, and we're going to have another one on the top. This is going to be for the motor boss, and if you don't know what the motor boss is, it's just like the little thing that sticks out of the motor that actually makes it turn. So we're going to have a circle right over here, and we're going to make it 0.8 for the motor boss. So with that, those are now defined, and next thing we're going to want actually is we want a center reference for the motor mounting points. So we know the motor is going to have some mounting points right over here, but to reference that, we're going to do another center circle, and we're going to do construction geometry this time, and we're going to have this to be 2 inches in diameter. So with that now out the way, we have the reference for us to actually make the little holes. So now we're going to come over here, get another center point circle, take out the construction, and make sure it is horizontal to this line and concentric to the reference we just made. And then we're going to have this to be 0.201 with after circle. And this is the important part, guys. So I could just make another hole right over here, like how the how the instructions show, and you can. But the easiest way to do it is just press mirror, and mirror it from the vertical line, and just press this so that now it's mirrored right over there. And that's really good because it kind of cleans up the area, because I'm not actually having to dimension that because there'd be another dimension over there. So it just makes it way more cleaner and way more simple. And you're going to see when I continue this part, it's going to get so much faster because I'm using mirror. So with that out the way, now with the mirror command done, you guys want to go over to a center point rectangle now. Make sure this is construction geometry, as it's going to be the reference holes for the actual mounting plate. So we're going to plop this right over here, and we're going to want both these to be 3.25 and as well 3.25. Alright, that's exactly what we want. Sometimes what's a good thing I'll do sometimes is just move these dimensions around just so it looks cleaner for y'all to see and just cleans up the CAD a bit. So we're gonna go over to center point circle and we're gonna press this right here and same thing, 0.201 inches in diameter. And let me just move that real quick. It's kind of hard to see. Okay, so this is where mirror comes in clutch. So I'm gonna come down here, go over and mirror this right here. So we have that, and I'm gonna cancel it, go back to mirror this vertical line, and now just click these two. And that just saved me all having to dimension all those separately. So that was very nice with the mirror function. And with that out the way, we're gonna want to go over to a center point arc, and we're gonna start it right over here and just extend it. Make sure there's no dimensions. You don't want any dimensions as of now. I mean, constraints, I should say. My bad. And you're gonna have this to be 3/16. So remember, Onshape automatically transfers that to decimal, so that's really nice. I'm gonna switch over the point to the dimension to be down there just to clean it up a bit. And this is again where Mio saves the day for us. I'm gonna just use this mirror tool and I'm gonna mirror this line over. So now that is mirrored, so that is excellent for us. I don't have to dimension that. And now we're gonna create a line right over here so it can connect these two as they're now mirrored. And I'm gonna escape because we don't want to dimension that. And we're gonna use a tangent. So we're gonna go tangent these two lines. As you can see, they're now fully constrained. And next thing we want to do for the other side, now that we have that constrained, is just click the vertical line right over there and click all the plots we just made. So now as you can see, everything is fully defined on the other side and we did minimal effort, which is exactly what we want to do. So with that out the way, now we're going to go make a line at the bottom right over here to just connect these 2 points together. And no dimension again, but what we're gonna do now is we're gonna make the top, and the top can be a little challenging, like bring, oh, what reference do I use? But what we're gonna do right here is we're gonna connect these. Oh, we're just gonna make just a reference, make sure there's no like constraints here. So we're gonna have that right there, and we're gonna create another line. I'm gonna just use quick hotkeys. Hotkeys are really nice. Make sure y'all start using them. It's gonna make your CAD super quick. So I'm gonna use those hotkeys. And sadly, Centerpoint doesn't have a hotkey, but we'll just plop one. No, I don't want that. Actually, I'm gonna plop this right over here. So there and there. Perfect. So now with this, what we're gonna do is we're gonna make this concentric with these two, and again concentric with these two. Oh, that would not make it concentric. Concentric with these two. Perfect. So actually make this define how we want it to be. We're gonna make. I'm gonna come over here to tangent, make this line and this line tangent. We're gonna make this line and this line tangent, this line and this line tangent, and right down here, that line and that line tangent. Now it is still blue, and how we're gonna fix that is we're gonna make it right next to this concentric. So we're gonna come down here to concentric, this dot right here of the arc to this dot, and that right there is going to make it concentric to that. And lastly, we're going to come down here to these points, and we're going to move it in to make it concentric to here. And as you can see, everything is now fully defined and is looking really nice for us. So that right there is all you need to do. So that right there is going to be our moto plate done. So we're going to check mark that up and press extrude. Just press the sketch so everything we just made is going to get extruded. We're going to want an extrusion of 1/4 of inches. Alright, and with that extrusion, we just check mark, and that is, I should check mark, yeah, there. That is exactly what we want there. So that is looking perfect for us. So next thing we're going to do is we're actually going to get the spacer feature script out, and we're going to use this. So we're going to have it to where the external diameter is going to be 3/8, as you can see right there, and the length we're going to want it to be 5/8. So with that now out the way, we're just going to want to press the little circle right over here so it just makes the spacer for us real nice and easy, and just check mark that, and our spacer is now complete. So the next thing we're going to want to do is going to be the actual front plate, and the front plate as well can look a little bit tricky, but with the features we know up at the top, it just makes it really easy, especially this one right over here. So I'm going to click the front of the spacer and start sketching from there, and what we're going to do next is we're going to use the use slash project slash convert, which is going to use all the dimensions we just made, and I'm just going to press the whole entire plate, and it's going to project everything we just made. So an amazing tool, very nice. And make sure while you're here is to project all these corner holes to the side right over here. So we project all of these. Make sure to project the middle one because we'll need it. And then we're going to press escape. Now, we're going to delete all of these because we don't actually need these right over here. So we don't need that. And make sure as well, click that point and delete the use like constraints we have because we don't actually want to use the constraints that are actually on that point. So come over here, delete that. And now, with that out the way, we could finally come over to center point again. And we're going to use a center point arc. I'm going to just make it right over here. And we'll do some like this. And this is going to be 1.75 in radius. So with that now, what we're going to do is we're going to come over here to concentric actually, and we're going to make this hole or this point concentric with, oh, I didn't click concentric. Make this concentric to this point right over here, and we're going to make this point concentric with this point right over here. So with that now, I could, oops, sorry. Oh no. Yeah. Okay, that's better. Hold up, let me fix it. Sorry about that, guys. Over here. Okay, yeah. So over here in the front, I was meaning to move this a bit. Let me zoom in. Yeah, that's what we want now. So with that out the way, we're gonna make these two tangent to one another so that we could actually fully define this. So this will be tangent to that, and we're gonna have this make a tangent to that. And as you can see, everything is now fully defined just the way we want it. I'm just gonna move this and just clean it up a bit. And that is now exactly what you want. So we're gonna conform this sketch right here, go over to extrusion, and go over to the sketch, and we're just gonna extrude this, make sure it's new, not add. So it's what we want, a separate piece, and then we're gonna make this 1/4 with the green check. Yep, twice, and there you go. That is the part right there. So one thing to make sure you do. Oh, oops, almost forgot something. Actually, my bad. We're gonna make a shaft, I believe, a shaft generator. So we're gonna generate the shaft down here so that the mode is actually rotating something. So we're gonna make sure it is thunder hex, this third one. Make sure it's not 3 thunder hex. I did that once. It's gonna we need this because it's gonna be 1/2 thunder hex. You make sure that this is gonna be bolt and washer, and it could be blind. Just make this 4 inches, and we're gonna start it right over here at the beginning of this hole. Just click it, and it's gonna go the wrong way first, so you're just gonna flip the axis on that, and boom, voila, that is complete. So one more thing you should do, I recommend highly, is rename this. So I'm gonna rename this to motor plate, and oops, my spelling is bad. Sorry guys. Motor plate, and we're gonna rename this to outer plate. And the last thing you guys want to do before you go to the assembly is click all these three, not the thunder hex because it already has a material assigned thanks to the shaft generator, assign material, and make sure we come down here and it's 6061 aluminum. Just press it right there and hit the green check. And with that, that is your part fully complete, and I'll be right back to do the assembly with you guys. Alright everyone, I'm back and I'm ready to do the assembly. So what you guys are going to do is go to your assembly page and go to insert and make sure you add current document, and you go to exercise number 1 part studio. So you could go, ooh, kind of far actually, hold up. So you could zoom in and just place it really well, but kind of next to the origin. So make sure you check mark that. And the next thing you want to do is you want to right click on the motor plate and make it fixed, because that right there is going to make it so it doesn't move at all, and we want to make that because we don't want anything moving. And the next thing we're going to do is group these two just so that they'll always be together like so. And then now what you're going to do is you're going to move this spacer so you can mate it. Make sure you press the mate, or I just use hotkeys. I just press M to activate it. You're going to mate the side like so with this side. So now that's mated. Now you could copy it, paste it, and mate all three like individually, but like I said before, I'm trying to make it easy and like streamline it for y'all. So you're gonna want to go to replicate, press the spacer, move it to match individual edges, and you're gonna click each one of these so that it just mates it and creates one for y'all, like so. Real easy, real nice. So next thing you guys want to do is you want to come over here to MKcad and make sure to put configurable only and type in bearings. We're gonna want the Vex and West Coast products bearings, and we're gonna want the third one, 1/2 Thunder Hex, which is flanged. So we press that, go ahead and insert, and then now press it, go over here to copy, and then make sure to paste it, like so. So with that out the way, now we could actually mate these. So I'm gonna use the hotkey to start the mate up command. Gonna come over to that edge, come this edge. So now that is mated nicely. Now I can come over here and go over to this edge and then click this edge, flip it around, and then now that looks good, like so. Now keep the command open as you want to grab this edge and this edge so that now the axle is now made into place, like so. So the next thing we're gonna do actually is we're gonna go ahead and get our motor. Now it seems like it might have been a while since they updated like the motor they use in FLCdesign.org, because when I go to Falcon, there's not really the simplified one anymore. It's not just V1 and V3 or V1, V2, V3. I've seen that V1 works better to like represent it, so I just use long and make sure it's simplified with both Vex Pro on. So go ahead and insert that, and then next thing you guys want to do is want to go over here to Moto. Make sure to select configurable only and go to the gears. And you see we have Moto gears right here. And we want to go down all the way to where you see Falcon 20DP 12 tooth steel. So we go over here, insert that for us, like so. And now what we're going to do is we're going to go start mating. So here is the part right here. So you guys want to come over here to that line. You guys are not going to press the mate right here. You're going to hold shift so that you could come over here and mate it to the center. So now you have that mate. You guys are going to come over and just go to one of these faces and just press this to the center. That now it's made together. Make sure to flip it so it actually looks nice. And like so, that is exactly what we want. It's looking good. So now we press this edge of it so we could mate it to this edge, flip it around, and now as you can see our motor is nice, looking nice into place. So that is what we want. And now we're going to come over to MKcad once again. Going to go over here to spacer, configurable only, and all the way down to Vex hex spacers. We're going to make sure this is 1/8, and we're going to go ahead and insert. And then now for the gear, we're going to go over here to gear, make sure it's configurable, 20DP, and then come all the way down to 40 tooth. Now, you might be wondering, like, wait, I thought you said you were going to use 60, and that is true, but I'm here to show y'all something, so just to make it easier, just in case a mistake happens, or you're just wondering. So, we're going to come over here to mate, grab this edge right over here, and mate it towards the edge of this bearing, like so. So, I'm going to check mark that right there. I'm going to come over here to the edge, and I'm going to edge that gear right over there, so that to make the edge to over here this spacer. So that right there is looking nice. And the thing I wanted to show you specifically, right, is as you can see, these are not meshing, but what you could do is if you right click, go over to change configuration, you could switch this now, come all the way down to a 62, and with that, you just click conform. And with all the dimensions we did, those two are now beautifully meshing. So that means all the dimensions we did is correct and looking nice. So now to actually bulk this whole thing. So we're going to go here to MKcad once again. And we're going to go over here to 1/4 by 20 bolt and washer. Just select that right over there. And we're going to mate this to the axle so that like it can't, slide out in the actual design. So come over here, click that, flip it around, check mark it, looking nice. And same thing as before, we're going to go to replicate, click the application. This time you could have match edges on face. That is perfectly fine for this one, as we just come down here, select this, and bam, that is done. So that is complete. And now for the last part, for you want to come over to insert and go to insert standard content. This will be all your screws and everything, like just all the regular stuff I usually use on a day-to-day basis on mechanical. So we're gonna make sure that we are in socket head cap screw, like so. Make sure you're in hex 1032 and both the thread and length are 1/2. Make sure these things are all the same as mine. Go over here to insert. And what I really love about this is that I could come over here and it automatically will show the mate for me. So I could just come over here to insert and just go right next to where I want it, and it will automatically mate it for me, which is saves me so much time. So with that now, we could come over here to component and switch over to socket button head cap screw, which is what we need for the other ones. So make sure your 10-82 and the length is 1/2. And now you're going to come over here to insert, and you're going to insert this right over here on the edge, like so. And you're going to check mark that, as that's everything we need for that moment. So now we're going to go to MKcad one more time. Go here to 1032, thin, I should say. Yep. Configure, no, not configure, my bad. You're going to insert this thin jam nut. Go over here to mate once again. Fasten mate this. Mate the bottom of it, like so, into the top of that plate and make sure it's forward. So now that the nut is connected into the actual screw. So with that now, we could go over here to our good old friend replicate. We press the replicate right over here. We go over here to match individual edges. So now with the nut we just pressed, we can now just tap it over here and each one is getting replicated, so saves us a ton of time. And then last but certainly not least, we just go over here to replicate one more time, press the screw, then I go over here, make sure to press match individual edges, and hopefully, yep, it's working. And right over there, that should be the last screw. And as you can see, this right here should be your completed assembly. It's looking really nice, and that should be everything. It should have 19 instances, like the instructions show you, and hopefully it should be 2.3 if I did this right, which I believe I did so. But let me go double check exercise. Yep, that's pretty much 2.23. It's 2.29, but if you run it, it makes 2.23. And yeah, so that's going to be the end. I really hope you guys enjoyed it and this really helped you out. And I'll catch you in the next exercise. I'll see y'all. Peace out.